So this is a question related to the rate of reaction. The reaction is repeated at a higher temperature. All other conditions stay the same. Describe how the rate of reaction changes. Describe how the rate of reaction changes. Explain your answer using ideas about collision between the particles. Okay. So of course, I told you that the temperature is directly proportional to the rate of reaction. Okay. The temperature is directly proportional to the rate of reaction, right? So when the temperature increases, so the rate of reaction increases. You know why? Because temperature is directly proportional to the average kinetic energy. Temperature is directly proportional to the kinetic energy. So when the temperature increases, so the kinetic energy increases. So I can say more successful collision. There would be there would be more successful there would be more successful collision, okay, increases, or hence I can say the rate of reaction increases. Hence the rate of reaction increases. Okay, so this is of 2 marks. This is of 2 marks. So the first mark is of writing like the particle, like the kinetic energy of the particle increases, and another mark is for like there would be more successful collision. Okay, and hence obviously the rate of reaction increases. Okay, so in the third part they are saying the reaction is repeated using a higher concentration. The reaction is repeated using what? Higher concentration. So I told you concentration means the amount of substance. Concentration means the amount of substance, the number of particles. So when the concentration increases, so means that the number of particle increases. When the number of particle increases, so I can say the like the successful collision, like obviously there would be a more collision. Okay, there would be a more collision because the number of particle increases, and in the end I would say that the rate of reaction increases. So summary is that concentration is also directly proportional to the rate of reaction. Concentration is also directly proportional to the rate of reaction. Okay, like I would be writing that um, when concentration increases, okay, so the particles, there would be more particles, per unit volume. There would be more particles per unit volume. Okay, or when there would be more particles per unit volume, I would say that there would be a frequent collision. There would be what? There would be what? Frequent collision. There would be frequent collision. Hence, I would say rate increases. Hence, I would say rate increases. That's it. Okay. This is of 2 marks again. Uh, okay. So, so how a
Sir,
catalyst, yeah.
can you explain what you were doing the last class? Because your voice was lagging, so we didn't understand that much.
So I was saying in the last class that uh, we have some factors on which the rate of reaction depends. Number one, I told you the concentration. Okay. Then I told you the temperature, and then I told you like the pressure, and then I told you the catalyst. Okay, but before going to discuss that thing, we need to understand the collision theory. Okay, collision theory says that basically this is the theory which is going to explain how the rate of reaction changes upon changing the different conditions. So the first condition is the concentration. Okay, so And according to this theory, for a chemical reaction, the particles must collide with each other. Not only the simple collision, but they must do a frequent collision. Remember, okay, they must do a frequent collision. And not only the frequent collision, there must be a successful collision between the particles. There must be a successful collision between the particles. Remember, okay. So so when there would be a successful collision between the particles, of course, I would say that the rate of reaction increases. Okay. So that's why after discussing this, this is the first condition that is called concentration. What is concentration? Concentration means the amount of particle. Concentration means the amount of particle, okay, the amount of substance. When the number of particle increases, when the number of particle increases, so of course I would say the number of collision increases, and when the number of collision increases, so of course the rate of reaction increases. Okay. So this is the first factor. Okay. So I can say concentration is directly proportional to the rate of reaction. Okay. Concentration is directly proportional to the rate of reaction. If you have less particles, so there would be less collision. And if there would be less collision, so the rate of reaction would be slower. And if you have higher concentration, means you have more particles. And if you have more particles, there would be more collision. And if there would be more collision, so the rate of reaction would be higher. Are you getting my point?
Yes, sir.
And
Yes, sir.
afterwards, we have temperature. Temperature is directly proportional to the kinetic energy of the particles. I have shown animation in the last class, if you remember. So
Yeah.
when the temperature increases, so the particles would move faster. When the particle would move faster, there is a higher probability that they would be colliding in a more frequent manner. Like let's suppose if the temperature is lower, so they are colliding 100 times with each other. But if you would be increasing the temperature, so they would be colliding 200 times greater than before. So what does it mean? When I have increased the temperature, so in fact I have increased the kinetic energy of the particles. I have increased the speed of the particles, and of course, when they would be colliding with each other, so I would say that the rate of reaction increases. Okay, so same goes with the lower temperature. Same goes with the lower temperature. When the temperature decreases, so the kinetic energy decreases. When the kinetic energy decreases, so there would be a less collision between the particle. When there would be a less collision between the particle, so the rate of reaction decreases. Basically, they are directly proportional to each other. Same as concentration. Same as concentration. Like at a higher temperature, you can cook food in a less amount of time, in a limited time. But if you have a lower temperature, if you are not providing heat to that one, so means that you cannot cook your food in a limited time. It would take a lot of time because when the temperature is lower, so the kinetic energy is lower, so the collision is lower. When the collision is lower, so the rate would be lower. Simple. They are directly proportional to each other. And same with the pressure. Same with the pressure. When the pressure increases, so the volume decreases. When the pressure increases, so the volume decreases because they are inversely proportional to each other. In this, you can see that when there is a lower pressure, so the volume was higher. So the particles were far away from each other. There were less number of collision. There were a less number of collision because the particles are far away from each other. So when the collision is lower, okay, so obviously the rate would be lower. Remember, collision is your key point in this chapter. Frequently, we would be discussing this term. Collision, 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 Collision is higher, so the rate is higher. Collision is lower, so the rate is lower. Remember. So what are the things that increases the collision and what are the things that decreases the collision? That's the important point. So in the end, I would be discussing if the collision is higher, so the rate is higher. If the collision is lower, so the rate is lower. So this is the main thing. So when I have increased the pressure, so means that the volume is lower. When I have increased the pressure, so the volume becomes lower. Okay. So the particles come close to each other. When the particles will be coming close to each other, so as a result, I would say there would be a more successful collision between the particles, and I would say the rate of reaction would be higher. So this is about the pressure, okay? And and in the end, this is the surface area. Surface area is also directly proportional to the rate of reaction. When the surface area is lower, like if you are going to dissolve sugar in water, so you have a lump of sugar, like the size of the particle is larger, so it would take time to completely dissolve in water. It would take time. You know why? Because there would be a less collision between the particle of sugar and the particle of water. And when there is a less collision, so the rate would be higher, so the rate would be lower. And if you are going to dissolve sugar, like the grinding sugar, okay, you have grinded the sugar and now you are dissolving in water, powdered sugar, I can say. When you have powdered sugar, so the size of a particle is very small. So the size of a particle is very small. So
And
when
then
the
it
size,
dissolves really
yeah,
fast.
exactly. When the size is very small, so it would take your less time, or I can say the rate of reaction would be increasing. Simple. So that's the thing that I was discussing in that past paper. If you can see, uh, yes. So yeah, you can see this. The reaction is repeated using the large pieces of zinc instead of zinc powder. All other conditions stay the same. Describe how the rate of reaction changes. Explain your answer using ideas about collision between the particles. Collision between the parts. Then what would you say about that?
The rate of collision decreases because now there is a space for the particles to collide.
Yeah, exactly, because they are saying we are using large pieces of zinc instead of the zinc powder. Instead of the zinc powder. So when you are going to use large piece means that the surface area is higher. When the surface area is higher, when the surface area is higher,
Rate of
so
reaction
yeah,
decreases.
exactly. So there would be a less number of collision. There would be a less number of collision, and when there is a less number of collision between the particles, so of course the rate of reaction would decrease. So the rate of reaction would decrease. It's very simple. It's very simple concept. Are you getting my point? Okay.
Yes.
Yes.
And they are saying that, okay, three part A. The experiment is repeated using a lower concentration of hydrochloric acid. The volume of acid used and all other conditions are the same. Draw a line on the grid to show how the volume of hydrogen gas produced changes with time when the reaction is done with a lower concentration of hydrochloric acid. Okay, lower concentration of hydrochloric acid. So means that I told you concentration is
Less
directly
number
proportional.
of
Yeah, exactly. So of course, when you are going to have lower concentration of acid, so it means that the collision would be lower and ultimately the rate of reaction would be lower. So how can I
decrease.
how can I express this thing in a graph? They are saying They're saying draw a line on the grid to show how the volume of hydrogen gas produced changes with time when the reaction is done. So I would say that the line would be the line would be less steeper. The line would be less steeper, but it would end on the same point, just like that, just like that. So because the concentration is lower, so means that the volume of hydrogen gas that is being produced as a result of this reaction would be lower ultimately. So the graph becomes less steeper. This line is more steeper. This line is more steeper. What does it mean more steeper? It's producing more volume of hydrogen in a limited amount of time. But if you would be doing your experiment with a lower concentration, it would not be producing this much volume in the same amount of time. So you know why? Because ultimately you are going to use a lower concentration. So means that the number of particles are a less number of particles, and of course the collision would be lower, and hence the rate of reaction would be slower. That's it. Are you getting my point?
Yes, sir.
And B part 1, describe and explain using ideas about collision between the particles how the rate of the reaction changes when magnesium powder is used instead of magnesium ribbon. Magnesium ribbon means that
There is
magnesium
more
solid.
surface area.
Yeah, exactly. So the same thing we would be discussing in this. There would be a more surface area. Okay, there would be a like the size of the particle would decrease in the for
Sir,
I'm
but
talking.
they're saying the rate of the reaction changes with magnesium powder is used instead of
Yeah,
magnesium ribbon.
yeah, because means that instead of magnesium ribbon, like we are not
Yeah.
using magnesium solid, like the size of the particles is larger. Ribbon is
Yes.
larger in size and powder is lower in size. So ultimately, in the form of magnesium powder, the surface area would be higher.
It is more.
There would be a more number of collision between the particles. And I told you, when the collision is higher, so the rate is higher. When the collision is lower, so the rate is lower.
Rate is
Simple.
lower.
Yeah, exactly. In part two, they are saying describe and explain using ideas about collision between the particles how the rate of the reaction changes when the temperature of the reaction mixture is decreased. So when the temperature is going to decrease means that the
Less
kinetic
collision will take
energy,
place.
yeah, less collision, there would be less collision between the particle. You know why? Because the number of
Kinetic
like the
energy
kinetic
decreases.
energy of the particle is going to decrease. When the kinetic energy is going to decrease, so ultimately there would be a
They
less
will,
collision, and
yeah.
hence the rate of reaction would decrease. That's it. All the questions you will see would be the same type. Like you can see B part 1, describe and explain using ideas about collision between the particles how the rate of the reaction changes when the temperature of the reaction mixture is increased. In the last question they were saying decrease. In this question they are saying increase. So I
Increase.
would
So
say
that
when
is
the temperature is increasing, so the average kinetic energy of
kinetic
the
energy
particle
decreases,
exactly increases,
increases.
and rate of reaction increase. This is of 2 marks. This is
Collision.
of 2 marks. Okay.
Okay.
Easy chapter. Or describe and explain using ideas about collision between the particles how the rate of the reaction changes when larger pieces of iron are used. So means that,
Less surface area.
yeah, there would be a less surface area, there would be a less collision, there would be when there would be a less collision, so the rate of reaction would be slower.
Less.
Yeah, exactly. Okay. You can see like different years, but the style of the question is same. See this part 2, state and explain how the rate of reaction changes when the experiment is repeated using a piece of magnesium ribbon with the same mass as the powder. All other conditions stay the same. Include in your answer
Yeah,
ideas
less
about collision.
surface area.
Of course, of course. Or see this question number 4, part A. Mhm. Think about that. The rate of this reaction can be determined by measuring the decrease in mass of the reaction mixture. Describe one other method of following the progress of this reaction. Yes. Are you getting this question?
Sorry, I didn't get it.
I told you that we can measure the rate of reaction by different methods. We have physical methods, and then we have a chemical method, and we can also measure the rate of reaction by using the graph, by looking at the line that we did, and then we would be finding the gradient of that line. Then we would be determining the rate of reaction, whether the reaction is faster or slower. But this is very easy question. This is of 2 marks. In this question, you can see that the gas is being produced. The gas is being produced. Okay. So you can measure the volume of gas. You can measure the
Yes.
volume of gas. So at a certain time intervals, okay, like let's suppose it's 7:23 p.m. I have measured the volume of gas, that is 20 centimeter cube. That is 20 centimeter cube. Then I would be measuring the volume after 1 minute. After 1 minute, it would be 30 cm cube. Then after 2 minutes, three, four, five. Like I would be measuring the volume of a gas at a certain known intervals of time. Then I can take an idea whether the reaction is faster and whether the reaction is slower. Like, am I getting more amount of volume? Am I getting more amount of volume in a known time intervals? If yes, rate is higher. But the time is being passed. It's 7:24 p.m. Like it's now 7:40 p.m. But I haven't, like you can say, seen any of the gas in the syringe. I can say the rate is very slower. The rate is very slower. So this is one of the method by which can you can get an idea about the speed or the rate of reaction. So what you would be writing in the answer. So in the marking scheme, you will see that they have written like we would be measuring the volume of gas, and in the product side there is only one gas, that is carbon dioxide. So measure the volume of carbon dioxide at known time intervals. So after doing this, you will be able to discuss about the rate of reaction, whether this is faster and whether this is slower. Is that clear?
Sir, we have to only measure the volume of the gas.
Exactly, because we have two methods. Whether you can whether you can find the decrease in mass. As you can see, calcium carbonate is solid. Of course, when the reaction would be happening, so the amount of the reactant decreases. So you can take measuring, yeah, like you can say you can take weighing balance, and just you can weigh calcium carbonate. Let's suppose right now it is 10 grams, and after 1 minute, now you are going to measure the mass. It's not 10 grams right now, it's 9 grams. So after doing this, you can get an idea whether the rate is higher, whether the rate is slower. Whether the rate is higher, whether the rate is slower, of course. But they have mentioned the rate of this reaction can be determined by measuring the decrease in mass of the reaction. Describe one other method. I'm not supposed to discuss, like, again, that method that they have mentioned, like decrease in mass. We are supposed to write another method. Is that clear?
Yes, sir.
See this B part. Again, it's very easy. Again, it's very easy.
So rate of reaction will
The
be higher.
surface, yeah,
Uh,
the
yeah, they are
surface
saying
area increases.
in smaller pieces, right? So in smaller pieces means that the
Surface
surface
area
area is,
increases,
yeah, exactly. So the
or more
surface area
particles
is
can collide.
higher. Yeah, more particles can collide with each other. So the rate of reaction would
Collision increases,
increase.
rate
Yeah.
of reaction increases.
Good, 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 good. Okay. Mhm. Uh, mhm. They would be asking the same thing again and like you see this 9 part A. 9 part A. Describe and explain using ideas about collision between the particles, how the rate of this reaction changes when the concentration of sulfuric acid is increased. So concentration means that amount of particles, when amount of particles, so the number of particles would be increasing. So means that the collision between the particle would be increasing. When the collision between the particle would be increasing, so of course the rate of reaction is going to increase.
Also increase.
Yeah, exactly. And in the second part, they are saying temperature is decreased. Okay.
So
So hopefully
kinetic
this
energy
is good right
decrease
now. Yeah, exactly.
and collision decreases.
Okay, good one.
Rate of reaction decreases.